sharing it with them. And that seems to help them. So our plan today, or the discussion today, is correlation and regression. Now, last Wednesday, we went through the steps. And I had the fill in the blank notes. And included with those fill in the blank notes were some examples. So those are the examples that I'm going to pull from. On this fill in the blank, okay, the questions that are there are the questions that you'll see on the Module 4 exam. And if you need to take the final, it'll be the same questions on the final. Okay, they're worded this way, they're in this order, that kind of thing. Okay, as it relates to correlation and regression. So I'm just going to start with the first one. And the first example says, the following are advertised sale prices of color televisions at electronic stores. We're kind of having, they're not really having Black Friday on Black Friday, but they're having Black Friday sales all through the month of November and parts of December. So think about it this way, Black Friday's coming up. So here are the advertised sale prices of your color televisions at the electronics store, and they give you the list. Okay, so in the top row, they give you the size of the TV in inches. The bottom row gives you the sale price in dollars. And the question is there a connection? Is there a relationship? Is there a correlation between the size in inches of color televisions and the advertised price? And so the first question they ask you really is to identify which one of the variables, size or sale price, is going to be your independent. And then by default, the other one becomes the dependent. And again, Ms. Ralston doesn't typically try to trip you up. And so we follow kind of the standard guidelines in that when your data is presented in table form, okay, when data is presented in table form, typically your top row is going to be your independent and the bottom row is going to be your dependent. So using that logic then, by default, the size of the TV is my X and the sale price is Y. Even if you're not convinced with that, remember we had a little kind of cutesy saying. So if we think about it, the sale price depends on the size of the TV. Now we could flip it around and try to say size depends on the sale price, but that doesn't really make sense. And so if we use that kind of little saying that we had, again, that tells me that the first thing, the sale price is Y and the size is X. So there's different ways to make the determination. The easiest way is to look at the setup of the table. So my independent here, I would write, and on your test, it is multiple choice, so you would choose which one. And if my size is the independent, by default, the sale price is going to be the dependent. Now, I do want to actually show you how to create a scatter plot in Minitab, because on some of your homework, you may need to do that, okay? I do know that on the test itself, I give you the scatter plot as it's given here, but I want to demonstrate for you how to create that scatter plot in Minitab. It's not difficult. As is the case with anything, whenever we're going to deal with Minitab, you have to put your data in first, guys. And because we have two different variables, one that represents X and one that represents Y, we'll put the data in two separate columns. I tend to use column 1 and column 2 if they're available. mean, I could use 3 and 4 or 5 and 6, it didn't matter. But in this case, I'm going to put the X values in column 1 and the corresponding Y values in column 2. Now, it is important that you keep them paired the way they're presented. Okay, so I'm going to go out to Minitab first off, and I'm going to enter my data. Now, one of the things that I do to kind of help myself out is I'm going to label column 1 as the size, but I'm going to also indicate that that's my X value. So I type size, comma, X, because throughout this process, I need to keep in my mind which one is X and which one is Y. But if I have it labeled already for myself, it helps me out. I don't have to keep going back. Okay, so then we have sale price, which is my Y. And I enter the numbers. Okay, 9, 20, 27, 31, 35, 40, and 60. Notice they're not consecutive. They don't have to be. Then we go back and keep them paired up. So the 9-inch TV was 147, 20-inch was 187, 27 was 297, 31 was 447, 35 is 1177. That's 1,177. 40-inch was 2,177, and 60 was 2,497. Okay, so I've entered all of the data. And then I want to create a scatter plot, and I'll go back and put the steps back up here for you, but it's fairly simple because a scatter plot is a graph. So I go to graph, and the first option is scatter plot. We're going to keep it simple. I mean, there's lots of different things we can do, but we're going to keep it simple. I tell it, okay. Then I have to identify, and guys, be careful because Minitab kind of has this set up backwards. It wants to know the Y variable first, and I know that's in column 2. Again, I already labeled it as Y, so that helps me to remember. And then it asks for X, which is my size. Now, you could get fancy-dancy and go in and put a title and all that. You really don't need it because all you're going to do is just look at it here on the screen. You're not going to print it or display it anywhere. You're just simply going to use it to look at it. Okay, so this is the scatter plot that you would use to answer the 3 questions to try to decide whether or not you should proceed. Okay, so let me switch back. Okay. So using the scatter plot, and again, I know that on the test, it's printed on the paper, okay, but you're going to ask yourself, does there appear to be a pattern within the data points? And I would say, using my eyeballs, I'm going to say yes. Remember, at this point, we're using our eyeballs. Does the overall pattern appear linear? Could we imagine, drawing a line, and I'm just imagining it there, drawing a line through the middle of those points? And I'm going to say, yeah, I think so. And then we want to think about, is the overall pattern positive, negative, or 0? Well, it does appear as the size of the TV goes up, the price goes up. So the line does appear to go up as we move left to right, which means it would be positive. Remember, this is talking about the slope of your line. But we also talked about how that you do not get to rely solely on your eyes. Okay, you do not get to rely solely on your eyes. Okay, so then we move to question 4, which is also really step 4, and we're going to look at it from an algebra perspective. We're going to use a formula to calculate the linear correlation coefficient. Now, I need to give you a big caution here, okay? Because Minitab does not calculate the linear correlation coefficient directly, okay? Minitab does not give R directly. It gives you the information that you need to figure it out, okay? But it doesn't actually do it for you. What Minitab is going to give you is it's going to give you the value for R squared. And I can undo a square, of course, by taking the square root. So I'm going to take the square root of the R square value to find R. The biggest challenge with doing that is you have to be careful about this sign. That sign should match whatever you've said about the pattern. Is the pattern positive or negative or zero? Okay. So let's look at how do we get this R. Now, when we do this in Minitab, it's going to give you lots and lots and lots of information. Okay, here's kind of the steps that we do. And it's going to give us all of the information we need to finish the problem. But this is where we have to begin to get R. Okay, so I'm going back out to Minitab. We've already entered our data. So we're going to go to Stat, Regression, Regression, Fit Regression Model. Okay, so Stat, Regression, Regression again, Fit the regression model. Then Minitab asks, where is your response variable? Remember, your response variable is the Y, so it's in column 2. Then you either can use continuous predictors or categorical predictors. We are only using continuous. So then I have to tell it where is the continuous predictor, which is the X. And we did talk about the other day that we could have more than one X, more than one predictor. We're only considering one, okay, but you could have more than one. Okay, so I tell it, where is the response, which is the Y? Where is the predictor, which is X? And then I'm going to click OK. And again, you're going to get lots of information, so don't panic. Okay, here's what I need. The third header says model summary. Okay, so to get R, we're going to look under the model summary. And it gives us R squared. It says R squared is 80.00%. Now, guys, be careful because notice there's three different. You have here under the model summary, you have S, you have R squared, then you have R squared ADJ, which stands for R squared adjusted, and R squared PRED, that's R squared predicted. Okay, you need just plain old everyday R squared. And I need to convert that to a decimal. Okay, so R squared as a decimal is 0.8000, and I'm going to square root that to find my R. Okay, so using your calculator, we're going to take the square root of the 80% as a decimal, 0.8000, and we enter. And we get a value of 0.8945. 4. We usually round R to 4 places. Okay, so I've written it here on the paper. We took R squared, which was 80%, converted it to a decimal, and then I took the square root. And we said it was positive. So my R value is positive, and I'm going to emphasize that it's positive. I'm going to put a plus sign here. 0.8944. So again, remember your R value is between -1 and +1, and the closer you are to 1, the stronger the relationship. Well, 0.8944, that's kind of close to 1. So again, my gut's telling me, yeah, there's a relationship. But remember, we don't get to rely just on our gut. We have to verify it or confirm it or prove it statistically. So then we perform, and my papers are stuck together, then we perform a modified hypothesis test, okay, to determine if R is statistically significant. The first step is you state your hypotheses. The hypotheses are always stated this way. Rho, which is your population linear correlation coefficient, equals 0 for the null, and rho does not equal 0 for the alternative. That's how you state them, and that would be the choices that you would make if you're taking your test or doing your homeworks. Okay, now, as a side note, let me remind you what that means. Remember, when rho is equal to 0, there is no linear correlation, and R is not statistically significant. We talked about that last week. If rho does not equal 0, then there is a linear correlation, and R is statistically significant. Okay, just as a side note to help you remember what those things mean. Then we need our p-value, which Minitab has already calculated. When we did that stat, regression, best fit, it calculated it in these results, okay? We look for the p-value under the header analysis of variance, and you look at this p-value that's out here to the side, the one next to regression, okay? So when this asks you for the p-value, you're going to look under the analysis of variance header, and you're going to read the p-value for regression, which in this case, that p-value is 0.007. If I get to going too fast, y'all stop me. Okay, then we're going to make a decision about whether to reject the null or fail to reject the null by comparing that p-value of 0.007 to alpha, which is 0.05. So again, we're going to compare p to alpha, just like we've done all along. And if you compare it digit for digit, you have 0 compared to 0, 0 compared to 5. 0 is less than 5, so p is less than alpha. Now, it's really always p is less than or equal to alpha. When p is less than or equal to alpha, same guidelines as we've always had, we're going to reject the null, which means the null is false and the alternative is true. So the follow-up question says, is the linear correlation coefficient statistically significant? The alternative is true. The alternative means that R is statistically significant. So I'm going to say yes, the linear correlation coefficient R is statistically significant. And then it says, is there a linear correlation? Guys, if you say yes, R is statistically significant, you have to say yes, there is a linear correlation or there's a connection. Guys, these two answers, the answer for D and number 6 should always match. It's either going to be yes, yes, or no, no. Okay, they should match. All right, then it says use the calculator. We're actually using Minitab to determine the line of best fit. Okay, so once we've decided that a relationship exists, remember, then we want to find the model for that relationship. So when we get to step 7, we're now at the regression procedure. Up to that point, we were at doing correlation. Again, Minitab's already done that for us. If I go back to my results, and the very first piece that I'm given is the regression equation. Okay, so we're going to look at that regression equation header, and we're going to write it down. Now, I have it here as y hat. You'll also see it written y with a little tick mark. Different notations, different researchers. So we have y hat equals, and I'm going to copy the numbers, negative 749 plus 54.8x. Now, again, as a couple of little side notes here, remember this number here, the 749, is your y-intercept. The plus 54.8 is your slope. Okay, let me go back where you can see my writing. Okay, I copied it from the screen. Y prime or y hat equals negative 749 plus 54.8, which is my slope. Now, what that's telling us, you're not asked what it's telling you, but what it's really telling you there is that basically the price of the TV goes up by $54.80 for every inch that it increases, roughly. 1 inch bigger, you're going to have a price of about an additional $54.80. Okay, so then once you have the model, you can use that model to make a determination. And they want us to predict, see, here's the prediction, when we have a 55-inch color television. Well, remember, the 55-inch is my size, which is X. Guys, it's a simple flat out plug and chug. I'm going to plug 55 into the equation that we just found in question 7. So I would have y prime equals negative 749 plus 54.8 times $55, or 55 inches, excuse me. So we go out to our calculator, and I'm going to type negative 749 plus 54.8 times the 55 inches, and we enter. And we get a value of $2,265. That would be our prediction. Straight, flat out, plug and chug, basic algebra. Okay, then question 9 says, using the coefficient of determination. Remember, your coefficient of determination is r squared that we looked at earlier, which is 80%. Is the size of a color television a good predictor of the advertised sale price? And remember, I told you there's really some more math that goes on behind the scenes, but our rule of thumb is if r squared is greater than 50%, then we say, yes, it's a good predictor. And so I hope you realize that 80% is greater than 50%. So we could say, yes, that the size of the color television is a good predictor of the price. Now, the other piece that I don't, well, actually it is, it's on the next page. The last piece that you have to do, and it's the one that students get tripped up on probably the most, is writing the explanation of the coefficient of determination. And I had that on the fill in the blank notes, okay? It's worded the same way every time. So in this case, we would say approximately 80% of the variation, and I'm writing that in caps because it's important, in the sale price is determined by the variation in the size of the color TV. Okay, approximately 80% of the variation in the sale price is determined by the variation in the size of the TV. Now, the pieces that change, of course, this percentage is going to change from question to question. Your variable will change, and the first one is always the y, and the second one is always the x. And you should have, again, those words variation are important. You got to have the word, the variation word in there those 2 times. How you feel? Okay, I want to walk through one more so that you have 2 examples. Okay, and I think this one has a negative correlation, and so that'll give you one with a positive and one with a negative. Okay, so the second example in your notes says, we are interested in exploring the relationship between the weight of a vehicle and its fuel efficiency. The data in the table show the weights in pounds and the fuel efficiency measured in miles per gallon for a sample of 12 vehicles. Now, again, based on the presentation, I would anticipate that the weight is X and the fuel efficiency is Y. Again, if you think about our little saying, we're saying that the fuel efficiency depends on the weight, which I hope kind of makes sense to you in terms of a vehicle. But again, I can look at that table, and again, because weight is in the top row, it is most likely the independent variable. Again, Ms. Rawson's not going to try to trip you up, and that's the standard. The independent would be on the top row, the dependent on the bottom row. So my independent variable here is weight, and it's measured in pounds. And my Y variable is my fuel efficiency, which is measured in miles per gallon. Now again, for your test, I know that the graphic is there, okay? The graph is there. But should you need to create it, this time I may, instead of using column 1 and column 2, I may use column 4 and column 5. And I'm going to have weight. And again, I'm going to go ahead and identify that as my X. And I'm going to have my fuel efficiency. And that's my Y. Again, I like to label them from the beginning. It just makes it easier for me down the road. Okay, so I have 2690, 2580, 2680, 2740, 3000, 3410, 3640, 3700, 3880, 3900, 4060, and 4710. So there's my weights, and then I have to keep them paired up. So I have 25, 24, 29, 38, 24, 23, 20, 27, 21, 18, 18, and 16. Okay, so I've entered the data. This time I have my data in column 4 and column 5. So I go to graph. I want to create a scatter plot, keeping it simple. My Y variable this time is the fuel efficiency in column 5, and my X variable is the weight. Okay, and so you get this graph. And so again, you look at that visual, that scatter plot, which again I had on your paper, and you got to walk through the questions. Again, you're going to ask yourself, does there appear to be a pattern within the dots? Again, you're using your eyeballs. I would say yes. Does the overall pattern appear to be linear? If you have trouble making that decision, you can maybe hold your pencil up to the paper or to the screen and say, think about it. I would say yes. And then is the overall pattern positive, negative, or 0? I'm going to tell you guys, you're rarely going to get 0. So really it comes down to, is it positive or negative? And it does look like here, as the weight goes up, the fuel efficiency goes down. So I'm going to say negative. And remember, that's going to be an important in a minute when we calculate the R value. So based on our eyeballs, we believe there is a connection or there is a relationship, but we never ever rely solely on our eyeballs. So then I have to go out, and initially I have to calculate the R squared so that I can then determine my R. So going back to Minitab, we've already entered the data. Stat, regression, regression, fit regression model. My response this time is the fuel efficiency. The predictor is the weight. I tell it okay. And again, initially I'm looking at the model summary. and I want R squared. So my R squared is 53.06%. Now, if I convert that to a decimal, that's 0.5306. Okay, so from Minitab, I've gotten R squared. But I don't need, at this point, I don't need R squared, I need R. So I'm going to take the square root of 0.5306. And I have to make a determination about whether it'll be positive or negative in a minute. So again, using your calculator, we do second square root 0.5306, enter, and we get 0.7284. But then remember, go back, because we said visually that the pattern appeared to be negative. So that means the R should be negative. So my R value here is negative 0.7284. Again, thinking about, is that close to -1? Kind of, sort of. So then we want to confirm. Oh, come on. Whether or not it's really significant. So our hypothesis, our null hypothesis, is always rho equals 0, and the alternative is rho does not equal 0. Again, we talked a minute ago about what those mean. If you need to write that down again next to those statements, you can do that. We go back to Minitab on the analysis of variance for regression to pick up the p-value. I actually got the same p-value again. My p-value is 0.007. That won't always be the case, but it happened to be for the two examples that I have selected. We then compare that p-value of 0.007 to alpha, which is 0.05. Again, remember, we do it digit for digit. We already decided a minute ago that 0 is less than or equal to 5.5. So p is less than or equal to alpha. And when p is less than or equal to alpha, we do reject the null. So if you reject the null, remember that means the null is false and the alternative is true. And when the alternative is true, that means that R is statistically significant and there is a linear correlation. So it really goes reject, yes, yes. Then using Minitab, we get our equation. It's called the regression equation. And we have y prime equals 45.44 minus 0.00640 times x. Okay, that comes directly from Minitab. Again, just remember the first number without the x is your y-intercept. The number in front of the x, including the sign, is your slope. So again, notice here that your slope was negative and your R was negative. You can see it from that point too. Okay, so then we can make a prediction because R was significant and there is a relationship. So we're going to plug and chug. Again, they give us the weight, which was our X value. So we're going to have Y prime equals 45.44 minus 0.00640 times 3,500 pounds. So using my calculator, I would have 45.44 minus 0.00640 times 3,500 pounds. We enter. And I get approximately 23.04. So roughly a vehicle that weighs 3,500 pounds, we would anticipate about a 23 mile per gallon fuel efficiency. Then it says, is the weight in pounds, using the coefficient of determination, is the weight in pounds, again, the coefficient of determination is R squared, which we already determined to be 53.06, okay? And again, remember our rule of thumb is it greater than 50%? Yeah, just slightly, but we would still say yes. And then we interpret that, and again, this is the piece that, for whatever reason, gives students the fits, okay? So here's what we would say. We would say approximately 53% of the variation in fuel efficiency is determined by the variation in weight of the vehicle. So obviously, in this particular scenario, there's other factors or other things that we would need to consider when we're thinking about fuel efficiency. I mean, 53%, that leaves almost another 50% of something else that's affecting it. You know, could it be road conditions? Could it be tire pressure? You know, could it be whether you're in the city or you're in a rural area? So there's other factors that come into play. Now, correlation and regression don't really tell us that, but then we can begin to speculate and possibly do further research to see what else is affecting or the fuel efficiency of the vehicle. The other thing that I want to point out real quickly, notice this X value that we got that we were given. We were given an X value of 3,500 pounds. And if you go back to your data, in our data, we had a low of 2,580 and a high of 4,710. Most times, guys, when you're creating this regression model, you want to only make predictions within the range of data that you started with. So in this case, I really only want to consider vehicles that are between 2,580 and 4,710 pounds, which 3,500 pounds is within that range, so I'm okay. See, the challenge is if I go outside that, if I wanted to consider, well, what if the vehicle weighed 5,000 pounds? I'm outside the range of information that I have. And sometimes if you go beyond the range of the values that you have, your model breaks down. It doesn't work. Now you can go a little bit on either end, on the low end or the high end. So maybe going to 5,000 wouldn't be too bad. But if I wanted to say 6,000, that would be a big difference. Okay, so you have to be careful. It's called interpolation versus exterpolation. Interpolation means you're doing it within the data, which is what we prefer. Exterpolation is going outside the data. And again, you got to be careful going too far outside the data because, again, your model could and would likely break down. It was also true in the other one because on the first example, because we had 55 inches was our X value for the prediction, and our values in the data went from 9 to 60. So again, we're okay. All right, questions related to correlation and regression. Okay, so that finishes all of the content that we're going to talk about for this semester. Okay, that's all of the content that we're going to talk about for this semester. Your assignments for Module 4, let me stop this and stop the recording.